Welcome. This is part 3 of the lecture I gave to the Hampshire Astronomical Group a few weeks ago. Part 1 of the lecture covered some of the scientific principles that we're going to be using in these discussions, and part 2 covered the inner solar system. If as yet you've not seen these videos, go to the description box below and I've posted links to them there. Part 3 is about the outer solar system, the gas giants. Jupiter, Saturn, Uranus, Neptune, and, though it's not a planet, Pluto. Some people claim that these planets are warming due to an increased output from the Sun. We're going to take each planet in turn and see what evidence there is that it is warming, whether that evidence is scientifically valid, and whether it's consistent with the hypothesis that the Sun is causing global warming throughout the solar system. We'll start with the planet Jupiter, the largest of the planets. The main piece of evidence that is used to say that Jupiter is warming is the fact that new storms have formed. Another red spot at a slightly higher latitude has appeared. These giant red spots are like hurricanes suspended in Jupiter's atmosphere. Because of the nature of its atmosphere, these storms remain stable for many decades, and the appearance of a new one is supposed to be a harbinger of global warming going on Jupiter. Now there are several problems with this idea. First of all, the warming that is claimed is a prediction of a model, not an actual measurement. The way this works is that most of the energy from the Sun is absorbed near the equator of Jupiter. So a temperature differential is set up between the equator and the poles. That sets up an atmospheric flow that takes energy from the equator to the poles, just like it does on Earth. The idea here is that the storms actually inhibit that flow. The model predicts that at the equator, the heat energy will build up and the temperature will rise by many degrees, because the storms are stopping the energy flowing towards the poles. But what's not mentioned in these claims that Jupiter is undergoing global warming is that the same models also predict that the poles will cool by the equivalent amount. And the other thing that's glossed over here is that the formation of storms on Jupiter is not controlled by output of the Sun. It's controlled by internal processes in Jupiter, called Kelvin-Helmholtz instabilities. Now, if I had a couple of hours of your time, I could possibly explain what a Kelvin-Helmholtz instability is, but it would be dreadfully boring. So the fact that Jupiter's got a new red spot, and there's a prediction that it's warming, is not any evidence at all that Jupiter's undergoing global warming. One of Jupiter's moons, Ganymede, is also pulled into this argument. Ganymede is a peculiar moon in that it has a relatively smooth surface, like a marble. This is an indication that at one time it melted, and the claim of course is that that's due to global warming. But let's compare it to its neighbouring moon, Callisto, which is made very much of the same substance and is basically the same distance from the Sun. Callisto is not smooth, it's pockmarked with craters. The explanation of this is that Ganymede was once hit by a large object being pulled into Jupiter's gravitational field. The theory is that the impact was so violent that it melted all the ice on the moon, which eventually refroze. Even so, you can still see on the surface of Ganymede there are lots of craters. From the density and the size of the craters, we can estimate how long ago this happened, and it was over 1 billion years ago. The surface temperature of Ganymede is about 160 degrees Kelvin. That's 114 degrees below the melting point of ice. So you'd have to have at least 114 degrees of warming to melt all that ice. And you'd have to have it for a long time to melt all that ice on that moon. And that's not consistent with the global warming time frame that we have here on Earth. So all in all, the conclusions about Jupiter undergoing global warming can be summarized thus. There's no evidence at the moment that Jupiter is actually warming, or there will ever be globally warming. That's just a model. The models predict that some areas will warm and other areas will cool. The evidence that Ganymede is warming is over 1 billion years out of date, so can't really be taken seriously either. So the case for Jupiter warming is a failed one. So let's see if we have any better luck with Saturn. There are 2 reasons given why Saturn is thought to be warming. One, like Jupiter, new storms have been detected, and secondly, Saturn's southern pole has a hot spot. Both these points are easily answered. The issue with the storms is identical to that of Jupiter, that the storms are not created by solar activity but by internal processes of the planet. Secondly, the hot spot is not a global phenomenon but a local issue, and is thought to be likely due to seasonal effects. Saturn's seasons go on for 7.5 years, and this southern polar region has been exposed to the Sun for a very long period of time, so will warm up disproportionately. Like Jupiter, Saturn also has a moon that is often brought into the debate, Enceladus. There are three reasons given why they believe that Enceladus has been warming. Half the surface at one time has melted, there's signs of volcanic activity, in this case water volcanoes, and there's probably a liquid ocean beneath the ice. There are several flaws in the argument that this is all caused by the Sun. First of all, the albedo of Enceladus is very, very high, so it reflects most of the sunlight, so any changes in the Sun would be very ineffective against this near perfect mirror. They seem to skip over the question why just half the moon is warmed. Enceladus has a synchronous orbit, and that means that its face always points towards the planet, rather like our moon does. As it orbits Saturn, that means each face of the moon must be exposed to the Sun equally, so it should have melted all the way round, not just one half of it. Again, the timescale for the melting is all wrong. It would have taken millions of years for all this ice to melt and then refreeze again. So this is not on the same timescale as the global warming we're seeing on the Earth. The volcanic activity is likely due to tidal forces from Saturn. So this is another example of a moon being struck by an asteroid or a comet with an impact that's so violent that it causes the ice to melt and then eventually it refreezes. So we've had no better luck with Saturn. Again, the arguments fail. Uranus is an oddball planet, but it is key to this whole discussion. Although there are lots of claims that Uranus is warming, I was unable to find any scientific argument to support it. And that's probably because in the scientific literature it's widely accepted that Uranus is cooling. Measurements taken early in the space age show temperatures that are systematically higher than measurements taken recently. And of course, this is important because all you need is one planet of all of the planets to be definitely cooling, and that blows this whole argument out of the water. So we could stop here, but why not let's just finish off with Neptune and Pluto just to complete the set. So now let's take a look at Neptune. But you must remember, the further we go out into the solar system, the less we know about these planets, and the shorter the history we have of what's been happening on them. So with their incredibly long journeys around the Sun, we are seeing a smaller and smaller proportion of their climate year. The primary reason given for Neptune apparently warming is that it has brightened by 15% over the last few years. These pictures show that the southern part of the planet is getting brighter and hotter as time goes by. However, if the planet is brightened by 15%, that has very serious consequences if it's caused by the Sun. It would mean that the Sun itself would have had to have brightened by 15% at least. And I think we would have noticed that, because we would all be dead. Also, Neptune's moon, Triton, has been showing signs of warming. For the Sun to have brightened enough to cause the change in Triton that we have seen, Earth's temperatures would have had to have gone up by 10 degrees, which has not happened. So Neptune is a bust too from the point of view of the Sun warming the solar system. This is all a seasonal effect. Last, and by all means least, at least from respect to what we know about it, is Pluto. But how do you measure the temperature of a planet that you can barely see? Well, one way of doing it is using the scale height of the atmosphere. The scale height is proportional to the temperature. For a small object like Pluto, you wait for it to pass in front of a bright star and measure the attenuation of the starlight. If the planet is warm, then the attenuation will start at a higher altitude. If it's cooler, it will start at a lower altitude. This is precisely the sort of measurement that has been made to date. They've made two measurements of Pluto passing in front of a star, 38 years apart. The results indicate that Pluto has a larger scale height more recently than it did several years ago, despite the fact that it's moving away from the Sun. This implies that the temperature has gone up. However, we're not altogether sure of this, and this might be something like seasonal lag. For example, the shortest day of the year in the Northern Hemisphere here on Earth is the winter solstice, December 21st. But when is the coolest day of the year in the Northern Hemisphere? It's about a month later. That's the seasonal lag. But we know so little about Pluto and the composition of its atmosphere and its dynamics that it would be crazy to draw major conclusions based on it. It would be like going to Earth and choosing a random point and measuring its temperature, and then coming back a month later choosing another random point and measuring its temperature, and trying to draw a conclusion as to what the climate of the Earth is over the long term. It would be farcical, and that's what any conclusions drawn from Pluto would be. So the gas giants overall have been a bust as far as global warming is concerned. We've had one planet's warming that's clearly due to seasonal effects, that's Neptune, and we have one planet that's cooling, Uranus. Many of the claims of global warming throughout the solar system are bogus or are gross misinterpretation of published results. Many of the phenomena are local, not global. All of the observed changes on the planets, including the Earth, have perfectly reasonable alternative theories to that of the solar theory. And if we look at the solar radiance, there's been no significant change over the last 30 years. If anything, it's gone down. So the answer to the question, why is the solar system warming up, is it isn't. So that's it for today. Keep safe. Bye for now.